Hi everyone, Mrs. Slauson. So this video is to help you get started on the practice. So the practice you should be looking at is week 13, review 3, forms of factoring. So you might not be in week 13, but this is the assignment that was given to you based on the particular folder that you're in. So don't worry about the week, just pay attention to the assignments that you've pulled up from the underlying links. So this is kind of putting the three forms together, and what we're going to do is we're just going to take a quick look and do an example from each section so you can get these started. The most important thing to do is, as you're fully remote at home, is to read the directions. So these directions say just factor the greatest common factor, the GCF, out of each expression. That's all you're going to do, and when you're done with that, you're done with the problem. So the problem I'm going to pick is number 2. So first, every problem on this page does need to be in standard form, so the highest exponent, and then the next till you get to just the constant. And then one of our goals is, when we start to put all the puzzle pieces together, is our leading term has to be positive. So as soon as you see that it's negative, your GCF that you're going to factor out is at least going to be a negative of some sort. So from there, what I look at is 12, 8, and 16. And what's the biggest number that can go into all three of them? So I always start with the smallest number. I look at 8, and although 8 can go into 8 and 16, it cannot go into 12. So if it's not the smallest number, then the GCF's even smaller than that. So 7, 6, 5, 4, 3, 2, 1. So as it turns out, 4 will go into all of these, and more specifically, I'll take out a negative 4. The next thing I'm going to do is look at how many A's there are in each term. So there's 2 A's here, 1 A here, and none here. And so what we need to do is see if we can take an A or A's out of each term. And since this term doesn't have any A's in it, we won't be able to do that. Okay, so in this problem, I'll just be factoring out a negative 4. And so when I finish my parentheses, I'll need to ask myself, negative 4 times what makes negative 12? Well, that will be a positive 3, and there will still be the A squares there. And then negative 4 times what makes 8, and that's a negative 2, and it still has its A. And then negative 4 times what makes negative 16? That will be a positive 4. So that's that example. Let's take a look at the next section and do one from there. So here you're going to factor each quadratic trinomial using an x. So again, this is just review, and I should have said that in the beginning. It's just review. So here, just a reminder that we're going to make our x, and then that's it. So let's take a look at this problem. So we're going to make my x, and I multiply my first and my last. It is in standard form. And now I'll need to look at my list of factors for 6. So here they are. I would see that in my factor list. And the set that will get me to 5. So what I've told you before is, if you have a negative on the top and the bottom here, when you put your numbers on the side, you're going to at least have a negative. And the only way to get to 5 would be a positive 2 and a positive 3. So 5's out. I'll be choosing 1 and 6. And if this number's positive, that means there were more positives and fewer negatives. So from there, I don't need these numbers. They've done their job. I want the numbers on the side, so I'm going to go ahead and make my parentheses and fill in my x's on the left. And if you remember, this term and this term make this term. So the x and the x make the x squared. So now I just need to know what times what makes 2, and that's going to be a 2 and a 1. And then from there, I draw the face. So I draw the top of the face, the head, and the smile. And so 1 can make either of these numbers. So 2 is a little bit pickier, because 2 can make 6, but it can't make the negative 1. So 2 is going to follow this loop, and 2 times what makes a positive 6? That will be a positive 3. So the 6x is taken care of. And then 1 times the number to make negative 1, well, that would be the negative 1. And remember, the x is already there. And that one's factored. So 5, 7, and 8 are going to be very similar. And then you got 2 on the back, 9 and 10. What you're going to have to be careful with in 9 and 10 is when you do make your x's, or I'm sorry, your parentheses, and an x here, is that 4 and 1 can give you 4, but also 2 and 2. So you're going to have to figure out which set works. And 10 is very similar. And then the last one is you're going to factor the following using the difference of squares, if possible. So the difference of squares is very picky with what works. So first there has to only be two terms. The difference means there's subtractions. And then the squares mean that each term is a perfect square, so they have a nice square root. So this has a square root of 2x. This has a square root of 1. There are the two terms, and then there's the subtraction that meets the difference rule. So from there, you can make your two parentheses. You'll put 2x and 1 in both of them. So they're going to look really similar, but to change them up, you're going to make 1 plus and 1 minus. So those are the directions for week 13, review 3 forms of factoring.